Okay, I want to talk about radian measure and degree measure and how we can easily move back and forth between the two. Remember that we said pi is equal to 180 degrees. So if I'm looking at a circle, here is 0 degrees, here's 90 degrees, here's 180, here's 270, and here's 360. So if pi is equal to 180 degrees, that pi would be here. So pi would be halfway around, which means 90 degrees is going to be half of that, or pi over 2. 360 degrees is going to be twice that, or 2 pi, which means that 270 would be 1.5 pi, or 3 pi over 2. So because pi is 180 degrees, and what I'll do is I'll put my angle measures, or my degrees, in blue, and I'll put the radians in purple so you can see the difference here. But think about this for a second. If I divide 180 into 4 equal parts, so if I did 180 divided by 4, that would be 45. So 45 degrees, right, that's halfway between 0 and 90. So 45 degrees would be there. So I'll put the degrees on the inside. That's 45 degrees. There would be 90 degrees, and here would be 135 degrees. 180, and then add 45 degrees again, that gives me 225 degrees. Add 45, that takes me to 270, then add 45 degrees again, that takes me to 305 degrees, then add another 45, and that takes me to 360. Okay, but what are all of those in terms of radians? Remember that if I divide 180 by 4, I get 45 degrees. So if I replace 180 with pi, because it's equal to pi radians, then I can say 45 degrees is just pi over 4, right? If 180 degrees is pi, 45 degrees is 1/4 of 180, then 45 degrees is pi over 4. And that should make sense as we follow this around, right? 1 pi over 4, then another 45 degrees takes me to 90, which is 2 pi over 4, which then reduces to pi over 2. 135 degrees is 3 pi over 4. Add another 45 degrees, or another pi over 4, and that brings me to pi, right? Another pi over 4 would be 4 pi over 4. That brings me to pi. Add another pi over 4, that brings me to 5 pi over 4. Add another pi over 4, that would be 6 pi over 4, which is 3 pi over 2. Add another pi over 4, that's 7 pi over 4. Add another pi over 4 would bring me to 8 pi over 4, which reduces to 2 pi. So we can easily take an angle measure and convert it from degrees into radians very easily. Okay, so let's say, for example, I had 30 degrees. Okay, so if I have 30 degrees, how many times does 30 go into 180? Well, it goes into 180 6 times. That means every 30 degrees, I'm doing 1/6 of pi, which means every 30 degrees represents 1 pi over 6. Okay, so that would be 30 degrees. Then I'd have 60 degrees. Right, that would be another 30, then another 30 would bring me to 90, and then another 30 would be 120 degrees, and then another 30 would be 150 degrees, and then another 30 would be 180, and then I'd have 210 degrees, and then I'd have 240, and then I have 270, and then I have 300, and then I have 330, and then I have 360. Okay, so again, how did I do that? 30 goes into 180 6 times. So if I divide 180 degrees into sixths, right, that's increments of 30 degrees. So I'm taking pi and dividing it by 6. So 1 pi over 6 is 30 degrees. 2 pi over 6, right, I'm adding another pi over 6. So 2 pi over 6 is 60 degrees. 2 pi over 6 reduces to, whoop, I lost my pen here. 2 pi over 6 reduces to pi over 3. 3 pi over 6 reduces to pi over 2. 4 pi over 6, right? 4 pi over 6 reduces to 2 pi over 3. So this would be 2 pi over 3. This would be 5 pi over, oops, where am I? 5 pi over 6. Right here at 180 degrees, we're at 6 pi over 6, which reduces to pi. Then we're at 7 pi over 6. Then we're at 8 pi over 6, which reduces to 4 pi over 3. Here's 9 pi over 6, which reduces to 3 pi over 2. 10 pi over 6 reduces to 5 pi over 3. Then 11 pi over 6. And then 12 pi over 6. So these are the major values that you'll be working with most often, or some multiple of them. But to find any way to convert from radians to degrees, okay, if I'm going from radians to degrees, okay, so let's say I've got pi over 10 radians. All I'm going to do is use my conversion factor that pi is equal to 180 degrees. So in this case, I would put in 180 over pi. Okay, I do 180 over pi because that's equivalent to 1 because they're equal to the same thing. And cross out my pi's, I get 180 over 10, which just reduces to 18. So pi over 10 is 18 degrees. So if I'm going from radians to degrees, I just multiply by 180 over pi. If I'm going from degrees to radians, so let's say I have 10 degrees, and I want to convert that to radians, then I just flip my conversion factor. Right, if I want to do 10 degrees and I want to convert that into radians, then I would multiply that by pi over 180. 10 goes into 180 18 times, so I would end up with pi over 18. Okay, very easy to switch from radians to degrees and from degrees to radian. You just flip your inversion factor. Right, you want to eliminate the pi's when you're going from radian to degrees, and you want to eliminate the degrees when you're going from degrees to radians. A couple of other observations I want to make about this circle. These are the most common ones that you will use, but a few things I want you to notice. Remember that we're just taking increments of pi. We're doing depending on the degree measure that we're using. Right, so for example, 30 degrees are pi over 6 increments. So right, if you know that something is divisible by 30, so let's say you know that you want to find 210 degrees. You say, well, 210 is divisible by 30, right? Just if I multiply 30 by 7, I get 210 degrees. Well, I know that pi over 6 is the equivalent in radians of 30 degrees. So if pi over 6 times 7, that gives me 7 pi over 6. That's 210 degrees. What you want to do is you want to get to a point where you can just think in radians, and it's not going to come right away. It's probably going to take a little time of using them on a regular basis, but it will become more natural the more that you use them. But if you're thinking in terms of the unit circle, if you look at all of the numerators here, they're all 1 less than the denominator. If you look at all the numerators down here, they're one more than all the denominators because they're just more than 180. These angles up here are just shy of 180. They're less than 180. So the numerator has to be smaller than the denominator. Here, the numerator has to be larger than the denominator because you're more than 180 degrees. So you're more than pi. Here, I'm not quite 360 degrees. I'm not quite 2 pi. So that numerator is going to be 1 less than twice the denominator. So all of these things fit nicely together. It's just a matter of getting comfortable with using radians and degrees. Hopefully that helps. We'll see you next time.